All right, let's go on page 99 when we're done. So in Unit 1, we solved inequalities of polynomial and rational functions with a number line. Remember number line? Is it positive, negative, so forth and so on. So we're also going to do that using trig, sometimes with a number line, sometimes not. And of course, since it's trig, it's all a little bit different. So we're going to start with this graph. And it says the graph of f is defined from negative 2 pi to 2 pi. That's what we see. We want all the values of x for which f of x is less than or equal to 0. So looking at this graph, when is the first time it is less than or equal to 0? Okay, so negative pi, but this is not the first time. When's the first time it's less than or equal to 0? Negative 2 pi. It's 0 here, right? So negative 2 pi. Then it goes to positive, so it's not an interval, it's just that point, right? And then, yes, from negative pi, that's the next time it's 0, then it's less than 0, then it's 0 again, right? So then we go from negative pi, oh crap, you're right, negative pi to 0, but this is an interval. Do I include these two or not? Yes, okay? So I'm going to include them. So I said yes, and then I didn't. Yeah, wait, thank you. That's what I'm trying to do. I'm trying to be as confusing as possible. Sorry. All right, then what's the next time it is equal to, less than or equal to 0? Pi. And then I'm going from pi to 2 pi. Okay, do I include these? Yes, and I actually will this time. We good with that? Okay. I hope so, because that was fairly simple, and it even says, solving inequalities is easy when you are given a graph. Yeah, because it's just one point, so it's not an interval. We're not going from it, it's just like one thing. So it's easy when we have a graph, but if only all problems were so simple, and they're not. So however, we must also understand how to solve inequalities in analytical form, which is algebraic form. For simpler inequalities that involve one trigonometric expression, we can often just use our understanding of the unit circle to solve it. That's saying instead of doing a number line and making it complicated, we can just use our understanding of the unit circle. If you don't have an understanding of the unit circle, this is going to be very difficult. All right? So let's look at this. Okay. Okay. I want all the values of theta between 0 and 2 pi. Would I include 2 pi if it shows up? No, because of the way it's written, right? All right, so for which sine is greater than or equal to the square root of 2 over 2. So over here you have an entire unit circle, which you don't even need all this stuff, and you definitely won't get it every single time. But we know, so we want to look to see where does sine equal square root of 2 over 2. Well, that's at pi fourths and at 3 pi fourths, right? But I don't just want where it's equal to. I want where it's greater than or equal to. So when we do these, it's good not only to know where the angles land that we're talking about, but also the quadrantal values of either sine or cosine, whichever one we're doing. And this is sine. So just the sine values is what I'm going to write down. Sine is 0 here. It's 1 here. It's 0 here. It's negative 1 here. Okay? We good with that? All right. So then I want to, so if I have a value of square root of 2 over 2 right here, which I know it's written there, but it's hard to see. If my y values, because these are y values, these values are they go from 0 to 1, and square root of 2 over 2 is in the middle there. But if I head this way, my number is going from the square root of 2 over 2 to 0, so the numbers are getting smaller, right? So this is not greater than, this would actually be less than. But going this way, I'm getting closer to 1, which means it's greater than. Does that make sense? Heading towards 1, so it's getting bigger than the square root of 2 over 2. When I look over here, where I also have a square root of 2 over 2, same thing. If I go this way, they're getting smaller, so it's not greater. This way is the way it's getting bigger and greater than square root of 2 over 2. So that part, this is the part of the graph that I'm interested in. Everybody okay with that? So any angle that falls between here, would satisfy this inequality. The sine of any of those angles, whatever it is, even if it's not a special angle that we don't know, it's going to be greater than the square root of 2 over 2. Yep. So theta is equal to, so what is the angle there at square root of 2 over 2? Pi fourths. So I'm going from pi fourths to 3 pi fourths. Are these brackets or parentheses? Brackets, because I'm including it. Okay. All right. What questions do you have? Bless you. We good? Okay. Alrighty. So now we're going to let f of x equal 4 plus 2 cosine x, g of x equals 3. I want all the values of x, and this is my restriction. Would I include 2 pi on this one? Did I make that test that funny? Is it that funny? Y'all are silly. Would I include 2 pi if it showed up? Yes. Okay. And I want f of x to be less than g of x. So f of x, which is 4 plus 2 cosine x, I want that to be less than g of x, which is 3. Okay? And then we solve inequalities just like we do equations. The only difference is we have to flip the sign if we multiply or divide by a negative, right? So I'm going to subtract 4 from both sides, so I get 2 cosine of x is less than negative 1. So cosine, yes, now we divide. Cosine of x is less than negative 1/2. Okay? No, because I didn't divide by a negative. It is negative, but the negative came about because I subtracted. I didn't divide by the negative. No problem. All right, so we don't have the big old unit circle, but we don't need it. But you need a little x and y axis so you can think around where things are. Okay? This is purely cosine. So the first thing I'll do is put in my quadrantals. Cosine is 1 here, 0 here, negative 1, and 0. Okay? Those there to think about. Then, I know this is negative, but remember we can always think about positive first. What is the angle that gives me a cosine value of 1/2? Pi thirds, okay? But this is negative, so my first one would be what? In the second quadrant? What's my second quadrant pi thirds angle? 2 pi thirds, okay? And then the next negative one would be in what quadrant? Okay, it would be 4 pi thirds, okay? Now, I didn't even worry about putting it actually accurate where it is, which is totally fine. It's just in that quadrant. Okay, so now I think about, all right, well, it also would help you, I think, if we also just put in this negative 1/2. Like, that's not an ordered pair, and that's not how you would really write it, but I'm labeling it. That's the angle, that's the cosine value. Just helps me kind of figure things out here. If I want cosine to be less than negative 1/2, so I'm starting here. If I have negative 1/2, am I going to get numbers less than that if I head towards negative 1 or if I head towards 0? Negative 1, so I'm going this way. Negative 1/2, same thing. I'd head towards negative 1 and not 0, so this is the part of the graph that I want. You see how that works? Okay, so that means my answer is, and that's why I want this on here too, so I don't accidentally like write negative 1/2 or something. 2 pi thirds to 4 pi thirds. Is it brackets or is it parentheses? I think it's parentheses too, because we don't include what actually gives us that value. Okay. We okay with that? Right. Right. That fits between 0 and 2 pi, so that's all we care about. Is what? Because 0 and 2 pi are over here, it has nothing to do with my answer. Like, I can only give answers from here to here, but this is the only part I'm actually using. Okay? We good? All right. So let's look at this next one. Things are going to work out a little bit different here. So I've got h of x, k of x. all the values of x. Here's my domain restriction. And I want h of x to be greater than k of x. So 3 cosine x is greater than the square root of 3 plus cosine x. Yes? Okay, so I have 3 cosines here, 1 here, so I'm going to subtract this one over and get 2 cosine x is greater than the square root of 3, which means that cosine x is greater than square root of 3 over 2. Okay? All right, I'm going to start with my quadrantals for cosine. This is 1, 0, negative 1, 0. Right, we haven't gotten that far yet, but yes. Second or third. Yes, yes, yeah. Okay, so what angle gives me a cosine value of the square root of 3 over 2? Pi 6. Okay, so I got pi 6 here. And where else is cosine positive? 4th, and at 11 pi 6. Good. And again, I'm not being crazy accurate with where the angle actually is, but it really doesn't matter. I'm also, just because it kind of helps me wrap my mind around things, those are the angles, but I'm going to put the square root of 3 over 2 here also, so I use the correct values for the different things. I just think those are helpful things to do. Okay, so I want the cosine values to be greater than the square root of 3 over 2. So if I start here, am I going to get values greater than that if I head towards 0 or if I head towards 1? Head towards 1. Here, would I head towards 0 or 1? 1, same thing, right? All right, so this is the part of the circle that I want. Okay. Because the square root of 3 over 2, anything, if I'm on a number line and I have 0 and 1 and square root of 3 over 2 is here, then if I want something greater than that, I head this way. If I want something less, I head that way. Does that make sense? That's how I know. Okay, because I don't have to actually like have a value of square root of 3 over 2 in my head or anything. Yes? I don't see why they wouldn't be. It's the intervals that we write are not always connected together. We're about to look at that, but that pretty much should be, yes. Okay. I'm trying to think of a time when it wouldn't be. I can't think of a time when it wouldn't be, so I'm going to go with yes. But okay, so let's look at how we're going to write this out. Now, I want to remind you that this is on a circle, right? And we can keep looping around a circle. But when we look at our sine and cosine graphs, we have unrolled that and laid our angles down like an x-axis, right? So I want you to look at what we have here. Let's just make a little number line. We're going to start with 0. We're going to end with 2 pi. This is pi, right? Not that I have to put pi on there, but it just kind of helps halfway. So the two angles that we have here are pi 6 and 11 pi 6. So although they are connected on the circle like this, when you unroll that, because remember, we can only go from 0 to 2 pi. This part right here is this right here. And this part right here is this right here. So they're not connected on the number line. If we took that number line and made it into a circle, then they'd like click together like a necklace, right? Like these are the hooks of my necklace. I just whoop, click it together. But it comes unclicked here and unrolls, okay? So even though it's connected here, my intervals will not be, because I can't say that I'm going from 11 pi 6 to pi 6. That makes absolutely no sense. Even though quite a few of you tried to write that type of stuff with domain and range. Makes absolutely no sense. Right, but we can't use negative pi 6 either because we have to be within this. If I didn't have that and I was just looking for then I could, but because of that, that's why I can't. Okay, good question. All right, so here's what we write. So x is equal to, I'm going to start here. I'm going to go, and I'm going to leave off all brackets and parentheses first. We're going from 0 to pi 6. Okay? And then we're going to go from 11 pi 6 to pi. Okay, everybody good with that much? Okay, Looking at it from the circle, do I include pi 6 and 11 pi 6? No, because of this, right? So I do not include that. These are parentheses. Do you think I include 0 and 2 pi? Yes, because that's within that, right? And so this is, I actually include that here. If this didn't have the line underneath it, then I wouldn't. But because it does, it's in the middle of that thing. We just had to split it to write our intervals. Okay, does that help? What questions you got? Okay. Oh my gosh. Okay, yes. Yes, thank God. Like my old one? Yes. Okay. Solving trig inequality. Okay, so we've just solved some inequalities. We've already done that. But this is where at the beginning it said, if you have just one expression, you can just use what you know about the unit circle. That's what we did. Okay? Now we're going to have to connect that knowledge to our number lines when we have more than that. These rules here, or these steps, this is literally the exact same steps that we had before. You set it equal to 0, and you factor if you have to. You create a sign chart. Then you test positive and negative. You label them, and then you interpret. Same thing. But here's the catch. This says, remember, the signs will alternate if there are not any factors with even multiplicity, which some of you learned at that first review session, because I didn't talk a whole lot about that, because it doesn't always, we didn't spend so much time on it. It doesn't always get applied correctly. And this is actually only true for, this is only for linear factors. And I didn't catch that this was on here, so I didn't take it off. So it is a true statement, but not for trig. Okay? Because we don't get linear factors because we have trig stuff. So we're not going to use that fact. Okay? We could have just marked it out, but that's why it doesn't work here, because these aren't linear factors. We're not getting x plus 1 and x plus 2. We're getting stuff with trig, so it doesn't work. Okay, there's other ways to figure it out, but they're not so easy, so we're just going to do it this way, and it'll be fine. Okay, so what are all the values of theta from here, 0 to 2 pi, which this is true? So we're going to start by rewriting that. 2 sine squared theta plus sine theta is less than 0. Okay. Can I factor anything out? Yep, I can factor out a sine theta. That leaves me with 2 sine theta plus 1 less than 0. Then I'm going to do my 0 product property. So I get sine theta equals 0. When does sine equal 0? Where does sine of theta equal 0? What angles? 0 and pi. Is that it? 2 pi. Do I include that on this one? Yes, because of this. So I need that 2 pi there. If that was not an underline, then I would leave that off. Okay? All right, so then here I have 2 sine theta equals negative 1, because I skipped the equals 0 step. So that means that sine theta equals negative 1/2. All right, so when does sine equal a positive 1/2? What angle? Pi 6. Okay, and then what quadrants are is sine negative in? Third and fourth. So what's your third quadrant pi 6th angle? Third quadrant pi 6th angle. 7 pi 6 and 11 pi 6. Good. All right, so yesterday when we were solving equations and we got to this point, then we wrote them all out in a list. We're not going to do that right now because we're about to put them on a number line. But one of the reasons you want to get in the habit of putting them in order when you write them out is that they have to be in the correct order when you put them on the number line. Otherwise, what you got going on don't make any sense. Now, for this number line, because I have this domain restriction, I'm always going to start at 0 and 2 pi, and end at 2 pi rather, even if it's not part of what's over here, okay? So I would include it anyway because of that, but That's where it's got to be. All right, so then after 0, with all this stuff, what's my next angle? Pi. And remember, this doesn't have to be to scale, just kind of spread them out evenly. Pi, and then that means, then oops, I said that and didn't do it. Then 7 pi 6, and then 11 pi 6. Okay, so if you recall, what we did with this number line on the other stuff that we did is that we then chose numbers between each of these zeros, substituted it into the factored form to see what the signs were going to be, right? I don't care about actual values. So again, on here, I think it was very helpful. This is all with sign, right? So I'm going to put in my quadrantals. For sign, this is 0, 1, 0, -1. And then, if I want to pick something between 0 and pi, right, I could pick something like 1. It's right there between 0 and pi. Okay, I don't even have to pick the angle. Yes, I could pick pi halves and then say, okay, well, the sine of pi halves, that makes it positive, but I know that the sine value is 1. So the sine value is 1, that means this is positive. When the sine value is 1, 1 times 2 is 2, plus 1, that makes it positive. It's positive overall. Okay. Then I have to choose something between pi and 7 pi 6. Okay, 7 pi 6 is right here. And this is where things can get a little tricky because as far as, if we're only trying to pick angle measures, the next angle after pi that we understand is 7 pi 6. Like, we don't know an angle and its values there, but we don't have to. We know that this sine value 0, what is the value, what is the sine value of 7 pi 6? -1/2, that's where it came from, right? So -1/2. So what I really need is a sine value between 0 and -1/2. What could we pick? Something. What's a number between 0 and -1/2? -1/3. That work? Yes? Okay. So -1/3. So if I pick -1/3, and that is the sine value, it's not the angle, so that makes that negative, obviously, right? -1/3. So then -1/3 times 2 is -2/3. -2/3 plus 1, is that positive or negative? Positive. I don't even care what the number is, it's just positive. So that means this is negative overall. Then I'm going to choose something between 7 pi 6 and 11 pi 6. Well, let's choose this, right? My sine value is -1. So for this first one, this is negative. If I substitute a -1 in here, -1 times 2 is -2, plus 1 is negative. Makes that positive overall. Then I got to choose something between 11 pi 6 and 2 pi. Well, this is -1/2, right? Well, look at this. Between -1/2 and 0, could I choose -1/3 again? And if I choose the exact same number, is the exact same thing going to happen? Yes, which is what we were here, which means this is just negative. Now, this one happens to alternate. They do not all do that, okay? Just make sure you understand that. All right, so now I want to look at what I'm trying to actually find. I need this to be less than 0. That means I want it everywhere where it's negative, here and here. Okay, so then theta is equal to, I'm going from pi to 7 pi 6, parentheses or brackets? Parentheses. Then I'm going from 11 pi 6 to 2 pi. Parentheses. Even though 2 pi is included right here, 2 pi actually makes this equal to 0, and I don't want it to be equal to 0. I do. Remind me at the end. Okay. Good. All right. We good with that? Let's do this next one. Any questions? What questions you got? So we're going to do the same type of thing. Values of theta. Here's my domain restriction. Here's my equation. So let's rewrite it. 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0. Now, I can't just factor a cosine out of this one because I got that minus 1. This is a trinomial. It's a quadratic. It's going to factor into 2 binomials. A is not 1. If you can factor, which you should be able to factor, you can factor this even though it has trig in it. Just pretend like the cosines are x's. Okay, so I'm going to give you a minute. I want you to try to factor this, knowing what you know about factoring, because you don't have to know anything about trig to factor it. You have to know how to factor. So try it. At least try it. Don't be afraid to write stuff down. Okay? Are you going to be out tomorrow also, or just her? Okay. You too? Okay. Okay. All right. Well, then I'll wait till the end then. It'll be easier. Okay, in the interest of time, because I know they was coming on with announcements, I'm going to go ahead and work through this with you if you were thinking. So to do this, I would do 2 times, if I'm going to factor by grouping, 2 times -1 is a -2. I need 2 numbers that multiply to give me -2, combine to give me 1. That'd be 2 and -1, right? So I'm going to split that middle term. 2 cosine squared theta plus 2 cosine theta minus cosine theta minus 1 is greater than or equal to 0. That's the exact same thing I would do if those were x's and not cosine. And if I combine these back together, I get this back. So I have split that middle term. Then I factor by grouping. Here I can factor out a 2 cosine theta. That leaves me with cosine theta plus 1. Out of these two, I can factor out a -1. And that leaves me with cosine theta plus 1 also. All right, so then I have 2 cosine theta minus 1 times cosine theta plus 1 is greater than or equal to 0. It's just literally the exact same factoring as if it was 2x squared plus x minus 1. Exact same thing. It just looks weirder because you got cosines in there. That's it. Okay, we good? All right, so then we do our zero product property, right? And I can say that 2 cosine theta is equal to 1. So cosine theta equals 1/2. So what angle gives me a cosine value of 1/2? Pi 6, do you agree with that? No, it's pi thirds. And then what's my 4th quadrant pi thirds angle? Five pi thirds. I don't know these. All right, so then here, cosine theta is equal to -1. When does cosine equal -1? At pi. Okay. All right, so on my number line, we're going from 0 to 2 pi. What comes after the 0? What's the next one? Pi thirds, then pi, then 5 pi thirds. Okay. This is all cosine, so my quadrantals are 1, 0, -1, and 0. Okay, so we want to pick something between 0 and pi thirds, right? And whatever between 0 and pi thirds, up there I had to use the values and figure that stuff out because I didn't know any other angles. Well, between these two angles, I do know angles. Pi 6 is here, right? So this even though this value is 1/2, this value of pi 6 or whatever I choose would be square root of 3 over 2. Make sense? So I'm just going to choose that instead of trying to figure out something between 1/2 and 1, which I could do also, but like I literally know one of those. So if I put square root of 3 over 2 in here, square root of 3 over 2 times 2 is what? Is the square root of 3. Okay, so square root of 3 minus 1, is that positive or negative? Square root of 3 minus 1. Is square root of 3 bigger or smaller than 1? It's bigger. You have to have concepts of numbers and how they work. So it's bigger. This is positive. Okay, and then if I put square root of 3 over 2 in here plus 1, that's positive also. This is positive overall. Okay. Then I'm going to have to pick something between pi thirds and pi. What can I pick? 0. So 2 times 0 minus 1 is negative. 0 plus 1 is positive. That's negative overall. All right, so then I have to pick something between pi and 5 pi thirds over here. So what can I pick? 0. Won't literally the exact same thing happen? Yeah, negative, positive, it's negative overall. Then I have to pick something between 5 pi thirds and 2 pi. Well, I can pick, again, I know this isn't to scale because 5 pi thirds is actually right there. But I could pick the pi 6th angle, which would give me square root of 3 over 2 again. So this one is going to be the exact same thing as that one. Positive, positive. This is positive overall. Okay? So let's look at what we were actually looking for here. We want this to be greater than or equal to 0. So that's the positives. But it's greater than or equal to 0. That means these that we found, this is what makes it 0, right? So I have to include these no matter what. Pi thirds can get included right here. 5 pi thirds can get included right here. But look at pi. He's hanging out in the middle there all by himself. So he's not part of an interval, but we have to include him because he makes it 0. Does that make sense to you? So when I put this out here, theta is equal to, so I start here. I'm going from 0 to pi thirds. Do I include 0? Yes, because I'm including it here, and 0, yeah, so I'm including it. And I know I include pi thirds because it makes it 0. Then I have this guy, pi, just one little old angle by himself. And then I include this interval, 5 pi thirds to 2 pi. And brackets? Yes, brackets. Okay. What questions do you have? No questions? All right, good deal.